We have been building on Earth for thousands and thousands of years. Now it's time to learn how to build on the Moon and Mars. NASA and several other international space government agencies, together with private enterprises, they're actually planning to live on the Moon in the early 2030s, with a goal to eventually move to and live on the Mars in 2040s. We have to build a spaceport. The same as on Earth, we have airports and helioports. The same thing happens with the spacecrafts. So we are trying to design different scales, some smaller, some bigger, spaceports on the Moon. In order to build that, we have to have a good materials that can actually resist and that can be durable for such a high pressures and high temperatures when the landers are launching and landing.
Typically when a rocket will go and land on the Moon, it will kick up lots of dust and different things that can damage the astronaut suits. It can damage equipment on the Moon, and the dust on the Moon is known to be very toxic, and so it can also impact the astronauts' health as well.
We are trying to develop construction and building materials for extraterrestrial applications using only local resources.
So a future goal for NASA is to try and implement construction methods on the Moon. And so a big issue with that is transporting materials to and from the Moon from Earth. So a way to help with that would be to use a 3D printer on the Moon to print the materials there so that you don't have to go through the cost of making materials on Earth and then transporting them up to the Moon. Working for NASA has always been like a lifelong dream of mine. I've always thought it would be an amazing opportunity. And this is just getting my foot in the door, and getting to meet people has been amazing. And even though it's not specified for my major, it's interesting being able to work and learn different things that I wouldn't learn in the classroom setting.
They get a chance to have a hands-on experience to work on a NASA and space-related research and do development or space-related technologies. Maybe their background is not aerospace engineering, traditional, what you would think that NASA wants. There's still a lot of jobs and opportunities, even for the biology folks, for the civil and construction, environmental engineering folks to work for NASA. It's great for them to develop teamwork, interdisciplinary, collaborative skills, which will make them great employees in the future. Students gain a lot of different skills, I think, from technical, research, and also soft skills.
We would give weekly presentations on our progress, and so it helped learning how to present information and just talk to other people in a more technical way. Especially because I'm a transfer student, I found it kind of difficult to meet people on campus and get involved. And this has been a great way to meet other engineering students and people that have similar interests to me. Working with Dr. Miletić has opened me up to lots of different opportunities. Not only has she been helpful with career advice and internship opportunities, she's always sending me different things that I should apply to, which is really helpful.
I had two amazing mentors in my life, and I think they definitely switched the trajectory of my career and my life. So I would like to think that I'm doing the same thing when I'm mentoring students. Just that if I can do a fraction of it, that would be great.